Hey, and welcome everybody. Thanks for joining today for another monthly Dylibso Insider stream. We've got a fun one for you today. We're going to talk about one of the kind of OG Dylibso products. It was kind of one of the first things outside of Extism that we put out there to kind of help the Wasm community and um, bring some kind of maturity to the tooling around, adding some policy and security and just a better understanding about what's actually in your Wasm. And so I'm going to talk about Modsurfer, which is that tool. There's also a kind of a web application version of it along with a CLI, and then give a little bit of a demo about how it can be integrated into a product, and I'll demonstrate that inside our very own XTP. So let me clear some space here and get started. First thing I want to do is just talk about Modsurfer itself. And I think the best way to do that is to share the origin story. And so we kind of realized that just pushing up WebAssembly and pulling it into an application and executing it while having the benefits of WebAssembly and its isolation characteristics protect you from kind of the general concerns of untrusted code going haywire in a system. It doesn't mean that the code will always work, and it doesn't mean that you're always able to call the right functions or provide that module with the exports it needs. And so what the original Modsurfer was kind of the system of record that lets you track and load all of your Wasm into a centralized location, kind of like an artifactory kind of a system, but specialized for WebAssembly, where you could search Wasm code, find things based on the imports or exports, find things based on the source code that the module was written in. And we decided that actually this is better off as a kind of integrated tool via CLI. And what that allows you to do is take a Wasm module. For example, we have this small Rust code base, and it produces a plugin. And let's see what this thing is. If I go target the all right, so I've got a pretty small 200K bit of WebAssembly here, written originally in Rust, and without having the source code, I kind of don't really know what I'm dealing with, right? Like, it's just some binary, like, Wasm instructions packed into this file. I can't just like double click it and open it like I could a source file of like a JavaScript project or something. So when things go wrong, you kind of have to start getting creative about how to debug. And there's a lot of very low level tooling in projects like Wabbit, like Wasm Object Dump, that'll help you get started. But the output is fairly cryptic, and unless you kind of know what you're looking for, debugging using these tools can be painful. And they're excellent tools, but we kind of need a higher level abstraction, and that's where Modsurfer comes in. And so right out of the gates, Modsurfer in CLI mode gives you the ability to kind of generate, diff, and validate that a plugin works based on a certain policy. And that policy is encoded in what we call a check file. And a check file is really just some YAML that describes the components of a WebAssembly module. And so I'm going to look at one that I just generated based on that plugin that you saw. And we start off basically saying with a block that says, hey, what do you want to validate? What are the truths about this Wasm code that you expect to have by the time you ultimately want to run that inside your environment? And so if you want to just kind of blanket allow that WebAssembly, the system interface, the WASI imports are available, you can set that easily with a bool. I can list all the imports that I expect to be included inside this block. I don't think there's any that are expected to be excluded, but you could specifically call out that you want some to be excluded alongside the includes. And then you get to your export section, which are the functions. In Modsurfer, we really only are focusing about the functions themselves. You certainly could also be exporting a memory, but we are thinking about this from kind of an integration based on kind of call code inside this Wasm module, and the exports are at that entry point. So this function, this Wasm module should export a function to me called run function. It takes no parameters and returns in I32. And you can even get as specific to require that the module is precisely the code that you expect it to be using a hash. And Modsurfer will actually read all the function bodies and build up a SHA-256 hash of just those instructions inside that function. So this is not a hash of the whole module. This is actually a hash of the instructions in the body block of that function itself within the Wasm, which is pretty cool. And then you may want to say, like, you know what, I only want to have this set of functions in my Wasm code. And I also want to make sure there are never any more than like these 3, so I can set a max number of exports that are available. And then you can also get into details with the binary itself. So I can say, like, I want to make sure that if someone's sending me code, I'm going to validate that the size of that module is under some threshold. Modsurfer will pick basically, you know, if you do a Modsurfer generate on an existing Wasm module, it'll just pick the size of that and add maybe like 10% buffer to give you some headroom. And then we also do a full cyclomatic complexity analysis inside of Modsurfer. So we have 3 thresholds, a low, medium, and high. These are just kind of statistically average buckets run on a huge swath of Wasm code to determine what is low complexity in terms of its cyclomatic score, what's medium, and what is high. And then these can be set in your own environment variables if you're using the CLI to define your own threshold. So enough yapping. Let's go back and actually generate a check file. So I would say Modsurfer, let me bump this up a little bit here. Generate, and I give it a path to the Wasm code. I can optionally set its output for the YAML. So let's say mod.yaml. We already created this; it's already there. And once I have a check file, I can validate against that check file. So like I can say Modsurfer validate that this same plugin target matches this check file with the C flag, and I get no issues. It works. That's awesome. Let's go ahead and change that check file to just say, like, you know what, maybe we'll change the exports function to be run functions. And this will give us a report that says, you know, there's actually something fishy here. We expected that this function body to exist based on this hash. It wasn't there, and that is an ABI compatibility risk with a pretty high severity. And then lastly, that the exports run functions was expected to be included, but it actually was excluded. And this is a very high severity ABI compatibility issue, because if this function is not there, your host will try to call a function that doesn't exist, and you'll get a runtime error that's unlikely to be handled very well, because it's a pretty baseline expectation. So it's pretty nice to be able to get this little, you know, report out. We run this in CI in a bunch of places, so we can very quickly understand, okay, where is the problem? How severe are these problems? And where do we start to fix these problems? But you can also programmatically interact with this. And I believe output format will give me an option for JSON. So I can say, if I want to pipe this into kind of a script situation, I can do the same thing and get JSON out, so I can then programmatically evaluate what the module has in terms of some issues with Modsurfer sharing me how to fix them, which is pretty cool. So yeah, I'm going to also share a little bit about, you know, like what you can do with Modsurfer. But first, there's kind of a revamped version of Modsurfer. I'm going to put a link here actually into the chat so you can check it out yourself. It's at modsurfer.dylibso.com. And this is just a free tool that you can use whenever you like. It will extract code for you. Let's actually just do this using that same module. Where is it? Let's say, go here and find the code, and just drop it into this little drag and drop. We unpack that WebAssembly code, and we show you a bunch of details about it, which is pretty nice. You get to see, okay, if we can detect it based on some heuristics, what is the source language that produced this WebAssembly code? What's the size of the binary? Let's visualize that cyclomatic complexity, so you at a glance can get an understanding of like, whoa, okay, what's going on in this code? And then a bunch of other interesting kind of tabular data for you. Okay, what are the imports of this function? Let me list all these things plus their namespaces, as well as their parameters and results in the function signatures. And this is really handy if, like, you encounter an issue and you're like, well, I didn't define that function. Why is it in here? Where's it coming from? And you get to kind of just see the at a glance snapshot of what the code is doing. And then, as we all are increasingly seeing that AI makes its way into everything, this is just doing a give me some idea of what you think this module might do, what it's used for, based on the information that we can extract from it. And OpenAI gives us some insights and inference on, based on the functions, their signatures, their names, the namespaces, what is it doing? It's usually pretty bad, but hey, it's something to fill the space. And then some kind of cool detection about the code. So we can tell that this is a XDism plugin because it imports from a known set of namespaces. Similarly, that it uses the standard WASI Preview 1 set of imports. And if you click these, let's see if I can just do like a markdown. If you click one of these guys, they'll generate the markdown if you want to just like paste it in a GitHub repository or something, which is kind of fun, especially this one, which renders a static image of all that snapshot detail. So we use this. If you share a link to Modsurfer in Slack or something, it unfurls into this. So it's kind of fun stuff. So now let's like see this in action. We've showed quite a bit about what Modsurfer does. Oh, one more thing here that's really neat. In the case of like you have a XDism plugin where you have a WASI module that we know we can detect and generate the code for you to actually like call the thing. You can actually just like copy this code either into your project or straight up into your browser. And this is going to fail because this is not what the kind of input it expects. But if I rerun it and say, whoops, and say, what should this do? This should take an object and its fields, the values inside its fields will be redacted. I think I built this plugin to do this. So if I have something like hello world, we should get, the world scrubbed basically from the data. So this is Rust code on the fly being downloaded, executed inside the browser, just as kind of a fun way of exploring the code and seeing how it works. And in this experience gives you kind of a nice way to just learn a little bit about the code and the module. You can share the link to this. You can copy the Wasm URL if you want to use this as kind of a hosting source. And yeah, so the Modsurfer web app is pretty cool. It's modsurfer.dylibso.com. But because we do have this code open source as a library, as I mentioned, which is used in CLI, we can also integrate it all over the place inside of our products. And so we do that in a product that we have shown a little bit about called XTP. And XTP is a way to basically just get plugins into your app the fastest, easiest way possible. It's built on top of XDism. It has a bunch of great managed solutions, guest accounts, so you can give your customer, your user, the ability to push code in an authenticated way. We handle that and simplify it. Out of the box code generation for plugin users, developer experience, upload, storage, and delivery. And then what I'll show you how Modsurfer fits in is in this kind of testing and simulation thing. And so I'll do that with some code. And this is a project that this is the project that produced that WebAssembly that we looked at in Modsurfer, where it had that run function export. And this code was roughly generated, except for its implementation, by XTP. And it uses a schema that was defined in XTP that says, hey, here's a run function that we expect to be implemented. It should take JSON in, and it should return JSON out. In Rust, we are actually like lifting the JSON byte into a hash map where the key is a string and the value is the asserted JSON value. So you can see in this example, we are checking that each value in this object is a string. And if it is, we replace the characters of that field with asterisks, indicating that it's been kind of masked in some way. And this is great. This works. I can do an XTP. I'm logged into my CLI with my into my XTP account where I have access to push into a extension point. And if I do an XTP plugin push, it's going to build that Rust code, and it is going to then, you see here, waiting for a version to be processed. It's uploaded to XTP, and it's going to go through a series of tests, and it's going to check for very baseline things like, is this actually WebAssembly code? Can I integrate it into my host system? Does it meet the criteria that the schema has turned into a Modsurfer check file? So if that schema had a run function, we're going to expect that the equivalent check file that we would generate on the fly to validate this code has an export called run function. It takes no parameters and returns an I32. And if that all works, we should see that the plugin was processed, and you should see kind of a stream of output showing which validations were successful, which ones failed. Let me check while we're waiting on here on chat. It looks good. And yeah, I think we can wrap this in 10 minutes or less. So let's get back here. And sure enough, so we got an artifact validated content type. It is WebAssembly. We validated the check file in Modsurfer. And then we run through our own kind of host-provided simulations where the code is actually executed, assuming all of these things previously pass. So like, how can we get this to fail? How can we get Modsurfer to find something that's outside of the scope of its validation, its expectations? And one of the things about WebAssembly that is like less widely discussed. We all love to talk about the safety and the memory isolation and all the great things that come along with it. But a lot of the code ends up being very opaque. It's hard to determine really what is actually in this code, because by the time the code's compiled to Wasm, your typical code scanners aren't going to just like work. You can't just check that binary like you could if it's evaluating the source inside of a Git repo. And so to illustrate that, this is a module here that this library depends on. So this is one that we know. We actually trust this code. We've put this here, but you could theoretically assume this could be from Crates.io, for a Rust program. It's just a module off the internet. We don't really know who made it or what's in it or what it does. And if this module in particular actually had an import, a host function, which is effectively like an FFI dependency to kind of another library that lives outside of the kind of code base that we're in. This kind of remote function, this external function, an unknown func name, because we really don't know what it is or who did it. If it's present in the source code, it can make its way into Wasm. And if whomever made this library also makes like a reference to call this function in any way, and even if they don't use any results, it's just kind of a no-op, we'll see that this code actually ends up in the plugin itself. So I'm going to do, and I'm not going to push this yet. I'm actually just going to build it, and then we're going to do another quick little Modsurfer check to see what's in it. So we built this. I think I might still have this up. I do. I'm going to go and create a new module. Oops. And we will see in the imports that we have an unknown func in here. So, okay, that's different. And what we should also find is that Modsurfer rejects this thing if we try to validate again. And let me make this a little smaller. Yeah, validate. And let's just do the table. So yeah, obviously, okay, so I messed this one up, but you can see the unknown function here. There's a bunch of things that I had in this old check file that don't match, but the important part is that it actually failed the validation and included the thing that we expected it to catch, which was that the module itself has an import that we did not expect to be included, and yet it actually was. And again, this is a high severity ABI compatibility problem because if this import is expected to be fulfilled by the host from the plugin's perspective, and it's not, then as soon as you try to instantiate this Wasm code in your host, it's going to fail at runtime and cause problems. So like this is what we're trying to prevent from happening. And a very cool thing about XTP in its all of its wisdom is going to catch this for us. And so if I do an XTP plugin push, it's going to rebuild it, rerun through the processing. And in doing so, the embedded Modsurfer integration inside of XTP will catch that, hey, this actually has an import that wasn't defined in your schema. You don't know about this import, and we're not going to let this code land in the kind of validated artifact registry that XTP hosts, and therefore also isn't going to be available inside of your host application. You will not run into this scenario where you're executing code that won't instantiate and therefore cause runtime pain. And the processor is being a little slow right now. Sorry about that. But we got our results as expected. So we get this table, the Modsurfer validation failed, and the same value that you saw prior is here, where the imports include this function that we expected to be excluded. So that's Modsurfer in a nutshell. Use it in open source form if you like at github.com/dylibso/Modsurfer. It's a Rust library that you can use in your code. We also publish it in the form of a plugin. So if you want to use it inside of XDism, you can get modsurfer.wasm and use Modsurfer inside your XDism code bases. You can use it in your day-to-day work with WebAssembly and get a read on what's happening inside your code. And obviously use it inside of XTP, and we'll keep your apps safe and make sure that your Wasm code's not doing anything that you don't expect it to. Excellent. Well, once again, thank you everybody for joining today. If you have questions, please reach out. We're always free on GitHub and Discord. You can reach out over email or anything like that. I'm very, very happy to hear from you. So thanks everybody again. We'll see you next time, and have a great rest of your day.